A long time ago, if you had some food laying around that needed to be preserved, there were two options. You either transported the food to some very cold place, or used some kind of time-consuming preservation method. These days, however, we simply use a refrigerator. But how exactly does this incredibly important invention work? Let's start by taking a look at this schematic drawing. You can see that we've got an object with some water on top of it. This object could be anything, it doesn't really matter for now. Now we all know that when you put water onto an object and wait long enough, the water will eventually be gone. In other words, the object has dried up. This is because the water has evaporated. And yes, of course, water evaporates when you boil it, but it also evaporates very slowly at room temperature. There is something interesting, though, about this evaporation process. Evaporation needs energy in order to occur. So, if we've got this object with evaporating water on it, where is the water going to get that energy from? Well, that's right, the object. The water will absorb energy from the object in order to evaporate, which is why the object will cool down as the water evaporates. That's also why it feels cold when there is water on your skin. It's because the water absorbs energy from your skin in order to evaporate. The opposite is also true. When water vapor condenses, in other words, turns back into liquid water, it actually releases energy to its surroundings. So here's what you have to remember. When a fluid turns into a gas, so evaporates, it absorbs energy from its surroundings. And when a gas turns into a fluid, or condenses, it releases energy to its surroundings. These are the two principles that the fridge uses to keep your stuff cool. So now let's take a look at the refrigerator. On the outside of the fridge we've got a tube called the condenser, and on the inside we've got a tube called the evaporator. They are connected to each other through a very thin tube, also known as an expansion device. On the other side, they are both connected to a compressor. The entire system is filled with a special fluid for refrigerators, which is called the refrigerant. Now, the compressor's job is to maintain a very low pressure in the evaporator and a very high pressure in the condenser. It does this by simply sucking refrigerant out of the evaporator and pumping it into the condenser. The reason we can create such a big difference in pressure is because of the expansion device. If we'd just use a normal tube, we'd get a continuous flow of refrigerant with the pressure being the same throughout the entire system. But because we use this very thin tube, a pressure difference can be maintained. Okay, so how does this system keep your stuff cool? Well, it all starts here, in the condenser. The refrigerant is liquid, since the pressure inside the condenser is way too high for it to evaporate. Then the refrigerant enters the evaporator, where the pressure is suddenly much lower, allowing it to evaporate, which is exactly what it's going to do. As the refrigerant moves through the evaporator, it slowly turns into a gas, and while it does so, it absorbs heat from its surroundings, and in this case, those surroundings happen to be the inside of the fridge, so this is why the temperature inside the refrigerator decreases. When the refrigerant reaches the end of the evaporator, it has completely turned into a gas. It then enters the compressor, which pumps it into the condenser. Now the exact opposite happens. The gas enters the highly pressurized condenser and slowly starts turning liquid again. As it moves through the condenser, the refrigerant slowly becomes liquid, while it loses its heat to the air surrounding the fridge. Remember, when a gas condenses, it releases heat to its surroundings. That's why the back of a refrigerator is warm. Now the cycle is complete. This is how the fridge moves energy from the inside to the outside, cooling down your stuff. So, there you go. Now you know how a refrigerator works. I hope you've enjoyed this video, and thank you for watching.